Okay, this one is, what is radioactive decay? Hopefully you know the symbol. It means radiation. It means you wouldn't go near it because it can cause cancer, right? It can mutate your cells. So what is radioactive decay? So we know things like uranium undergo radioactive decay, and it's a terrible looking pen. We know things like uranium undergo radioactive decay. Uranium, if you look on the periodic table, has a mass number of 235, right? That's a really big atom, okay? Whereas if I look at something like hydrogen to compare it to, hydrogen has the number 1, right? Look, this one's 235 times bigger, right? That's a small atom, it's a really big atom. Look at something like lithium. Lithium's got mass number 7. Again, a small atom, a big atom. Uranium is a really large nucleus and it's unstable, okay? It's got 235 neutrons and protons inside its nucleus. In its nucleus, we know we've got all of these protons and we have all of these neutrons. So inside its nucleus, it's got loads of protons and neutrons. It is unstable, okay? So things don't want to be unstable, they want to be stable. So the only way for it to get stable is for it to become smaller. So it wants to become stable, it wants to get smaller. And the way it can get smaller is it can emit something, okay? So what the nucleus could emit is it could emit an alpha particle. It could emit a beta radiation, or it could emit a gamma wave, okay? They're always to get smaller. Okay, first one to talk about is the gamma wave. A gamma wave is an electromagnetic wave of radiation, okay? It's just a wave of energy. Technically, when the uranium emits that wave of energy, it's not really getting smaller, but it's losing energy, okay? It's still losing energy. It wants to become more stable, so it's still a good thing to do. So one thing to do is emit a gamma wave, a wave of electromagnetic radiation, okay? That one's highly penetrating. It can get through paper. It can get through wood. Okay, other things that can emit, try and get smaller, is an alpha particle. An alpha particle is a helium nucleus, and you need to know that. So helium on your periodic table has the top number 4 and the bottom number 2. You need to remember that in physics. So an alpha particle, what it is a helium nucleus, 4, 2. So what that means is the bottom number is 2. It's going to have 2 protons inside it, and 4 take away 2 to give us how many neutrons there are, which is 2. So 2 protons and 2 neutrons inside it. So what this uranium can do is it's really large, loads of protons and neutrons. It can emit 1 alpha particle. It can get rid of 2 protons and 2 neutrons in order for this to become smaller. Something else it could do is it can emit a beta particle. Beta particle is a fast-moving electron. And an electron now isn't any protons and neutrons. An electron doesn't have any mass and it has a charge of -1, okay? We can write a charge of -1 because here, that 2 again tells the number of protons. There was 2 protons. Protons have a charge of +1. So if I got 2 protons, it's got a charge of +2 overall. So that's why this tells me it's got a charge of +2. This one's got